Welcome back to Miss Max Academy. In this example, we are going to reflect triangle JAR across the line or over the line y equals x minus 3. So let's just take a minute and review what we know about reflections. The word reflect means to flip across a line. We know when we reflect a polygon, the original polygon, the pre-image, and its image after the reflection are congruent. They're called isometric, meaning that both the pre-image and image are congruent. And most importantly, we know that the line of reflection is the perpendicular bisector of the segment connecting each point to its image. So let's draw that line of reflection. The line we're supposed to be drawing is y equals x minus 3. Just a quick review. How would we graph a line in the form y equals mx plus b? Well, let's see, y equals 1x minus 3. So that means our y-intercept is minus 3. We start there. Here's our origin. We go down 3, 1, 2, 3, and we plot a point. That point is called our y-intercept. The next piece is we identify the slope. We like to write slope as a fraction. So if the slope is 1, we would write it as 1 over 1. Because the slope is positive, we know our line is going to be going up and to the right. So let's start at our y-intercept. We go up 1, right 1. Up 1, right 1. Up 1, right 1. Etc., etc. And you see we have here the graph of y equals x minus 3. So this is our line of reflection. This is the line we are going to flip triangle JAR over. So if we're going to flip across this line, we know JAR is going to end up over here somewhere. Let's go back to this definition. The line of reflection is the perpendicular bisector of a segment connecting each point to its image. Well, what type of line would be perpendicular to this line? Well, the slope of this line is 1. Just a reminder, perpendicular lines have opposite reciprocal slopes. What's the opposite reciprocal of 1? Well, the opposite of 1 is negative 1. The reciprocal means flip fraction. If you flip this fraction, it's still 1 over 1. So the opposite reciprocal of 1 is negative 1. So 1 and negative 1 are opposite reciprocals. And we know that lines that have opposite reciprocal slopes are perpendicular. And that's important to us. We want them to be perpendicular. So let's take a look here. If I wanted to move R across this line, I'd know I'd be going in this direction. The opposite reciprocal of positive 1 is negative 1. So I'm going to go down 1, right 1. Down 1, right 1. And this is where R prime must be. Well, how did I know that? Let's take a look. The segment connecting R to R prime is in fact at a right angle. You could take a protractor and measure this right here. This is clearly 90 degrees. It's at a right angle to my line of reflection. My line of reflection also bisects this segment connecting R to R prime. Okay? And if you wanted to think about it this way, it's one diagonal distance, two diagonal distances, and the line is cut exactly in the middle, right? So we went 1, we got to the line of reflection, we went 1 more, and again we talked about diagonal distances here, right? And we got to R prime. So I'm going to erase that so I have some room to maybe reflect a few more of the points. Sorry, I just had to redraw the line. Let's reflect A. Again, we need opposite reciprocal slope. So from A, I'm going to go down one, right one, down one, right one. I go down one, and I kind of bump into the line, so I go right one. And you see here that this diagonal distance is cut exactly in half by the line. So let's take a look at the pattern. We had 1, 2.5, right, in this direction. So we just continue on the opposite side of the line. 1/2, 1, 2. So this has to be A prime. This point right here has to be A prime. Okay, and again, if we drew the segment connecting A to A prime, we would see that our line of reflection right here cuts that segment in half, it bisects that segment, and it forms a right angle with that segment. So again, the line of reflection is the perpendicular bisector of the segment connecting each point to its image. Here, the original point was A, and its image is A prime. And finally, okay, sorry, I had erased the point for R prime. I'm going to reflect J across this line. And again, opposite reciprocal slope, down one, right one, down one, right one. Down one, right one. Let's see, so we have 1, 2, 3 diagonal distances until I get to the line. Down one, right one, 1, 2, 3. So this has got to be, let's make it a little bigger. This has got to be J prime. And again, let's erase all these little dots so it doesn't get confusing. And if I draw my line segments, here should be my final image after a reflection across the line y equals x minus 3. Let's take a look what that will look like. And again, we just want to check to make sure they're congruent figures. For example, the distance between J and A, up 1 over 2. Oh, here we go, down 2 over 1. That'd give us the same distance using Pythagoras' theorem. Okay, the distance R to J, down 3 over 1. Over 3, up 1, same exact right triangle, so it'd give us the same distance. So in fact, we do have 2 congruent triangles. So therefore, we did in fact create a good reflection. And let's take a look at our final product. Voila! Here is triangle JAR, and here is its reflection across the line, y equals x minus 3. And here, let me just identify the origin here. The origin was right here. So you can see, again, here's our y-intercept, down 3 from the origin. And here's the line, y equals x minus 3. All right, tune in again next time for Miss Mac's Academy.